Guys, my name is Christina Latimer. I am the project coordinator for the Environmental Education Initiative, and I get the pleasure of introducing this year's interns today. Every year, every summer is a different adventure. I don't know, it's always pretty fun, but I'm really excited for you guys to see all the hard work these guys have done. And to do that, I got to get out of the way. So thank you for being here, for supporting all of these amazing young people, and I'm going to let them get started.
Good morning, everyone. My name is Nisha, and welcome to our 2026 Dallas EEI final presentation. I want to start off by saying thank you all for coming today. This year, we got the wonderful opportunity to learn about water conservation and water quality in our city by going on field trips and doing in-depth research on these topics. We are so excited to present our findings and the experiences we had during our time together. Now, I'm going to pass it off to Eileen so she can go over what we're covering in today's presentation.
Hello. Thanks, Nisha. So here's a brief overview of the order we will be giving your presentation in. So first, we'll be introducing ourselves and telling you a little bit about us. Then we'll get into the details of the program and what we did, including meeting UNT researchers and presenting research articles or field trips, the research we undertook on water quality and water conservation, and including GIS and the statistics, and finally conclude the presentation with possible work and recommendation for next year's interns. So now we'll be talking a little bit about ourselves. So starting with me, my name is Eileen Guerrero, and I'm a rising senior at Ermarango Young Women Leadership School. And a fun fact about myself is that I enjoy doing community service to help other people. And for future plans, I plan on attending a four-year university and major in neuroscience.
Hello, everyone. My name is Abel Hernandez. I come from Adamson High School. My future plans is going to UTA at Arlington to get a degree in software engineering. And a fun fact about myself is that my favorite hobby is fishing.
Hello, everyone. My name is Alan Raimundo, and I'm a recent graduate from Seagoville High School. My future plans are that I will be studying civil engineering at UT Austin, and I want to be part of the U.S. Army Corps of Engineers post-graduation. A fun fact about myself is that I love resistance training because it makes me feel alive.
Hi everyone, my name is Dominic Ruiz. My fun fact is that I love to draw and I actually medaled twice in vase, and my future plans is studying marine mammal biology and caring for seals.
My name is Damon Walton. I'm a graduate from the Dr. L.G. Pinkston High School. I plan on attending UNT to major in business marketing, and one of the fun facts about me is I love basketball.
Hello, my name is Darius Sobasi. I come from the School of Science and Engineering Magnet. A fun fact about me is that I like to play the drums, and for my future plans, I plan to go to a career centered around neurosurgery and neuroscience.
Hello, everybody. My name is Hector Perez. I come from the School of Health Professions. My fun fact is I've interned at the surgical wing at Dallas Methodist Hospital. My future plans are to get a bachelor's of science in biology and then pursue my medical career further into orthopedic surgery.
Hi everyone, in case you forgot, my name is Nisha. A fun fact about me is I love poetry and I served as Dallas Youth Poet Laureate. I'm a rising senior at the Hockaday School, and in my future, I plan to attend University for English.
Hi everybody, my name is Sita Kodem. A fun fact about me is that I am actually double jointed in all of my bones. I'm a rising senior at the Hockaday School, and for my future, I plan to attend or university for mechanical engineering on a pre-medicine track.
Hi, my name is Olivia Owens, and I'm going to be a senior at Kathleen Joy Gilliam Collegiate Academy. A fun fact about me is that I love theater, art, and history, and my future plans are pursuing a bachelor's in environmental science, working in the habitat restoration field, and later on becoming a park ranger. And today I will be introducing you all to the Dallas Environmental Education Initiative, also known as Dallas EEI. I will discuss the organization's mission statement, its progress, and its goal. In the end, we will conserve only what we will love only what we understand, and we will understand only what we are taught. I feel as though this quote relates to the Dallas EEI movement because here we are dedicated to increasing environmental awareness, education, and stewardship throughout the Dallas community. The organization provides water conservation education to students and community members to encourage sustainable practices and responsible environmental decision making. The mission focuses on empowering individuals with the knowledge and skills needed to protect natural resources, improve community health, and create an overall more sustainable future for Dallas. Over time, Dallas EEI has built partnerships with schools, community organizations, and environmental agencies to aid in spreading the water conservation education. Wait, y'all give me. Okay. The initiative has increased community engagement. The initiative has increased community engagement through educational workshops, field trips, and hands-on learning experiences and environmental awareness events. These opportunities help students understand real-world environmental issues and encourage them to become active participants in solving those challenges. Through these efforts, Dallas EEI continues to reach a larger audience and inspire the next generation of environmental leaders. Now I'm going to pass off the mic to Abel to further explore our programs associated with our goals.
One of the programs that we have here is the elementary school program. It is used to teach elementary students more about water conservation by using hands-on lessons. Lessons are aligned to TEKS or the state standards teachers are required to use, and the teachers book them on the website during the year. A couple of examples that you can see here on the left, students are cleaning water in the urban water cycle, and on the right, students are graphing the types of water on the planet and creating water cycle bracelets. The students also receive different conservation items based on their grade level to show their commitment to saving water. For example, kindergarten through second graders get the coloring book, third through fifth graders get a toothbrush timer, and every grade level receives a commitment card where they make a promise into saving water by turning the water off when they brush their teeth. We then move on to professional development. In the PDs, the teachers take part in lessons with the EEI team. During the lessons and discussing the classroom strategies give teachers a hands-on experience. The teachers also receive all materials necessary to teach the lessons in their classrooms after the development. Now I'll pass it off to Hector.
Thank you, Abel. Like the elementary lessons, the middle school discussions are all TEK-based or aligned to the grades level's curriculum. The EEI middle school program is currently a museum on wheels. The EEI team takes their interactive modules to the schools and provides water conservation discussions with the students. EEI is evolving their middle school program due to teacher feedback and changes in the state curriculum. They are developing and testing hands-on lessons similar to those used in the elementary program. The image on the left shows Nick in the discussion with middle school students and the modules, and the image on the right shows the new hands-on activity. Like elementary students, middle school students are given the opportunity to commit to saving water using commitment cards. Instead of just agreeing to turn it off when they brush their teeth, students tell us what they are willing to do to conserve water. They are also given this shower timer to show and remind them about what they learned in school and apply it at home. I'll pass it on to Darius to talk about the high school summit.
Thank you. The Dallas EEI Research Summit is an opportunity for high school students to participate in hands-on water conservation research. For the summit itself, students propose a water conservation project. If that project is approved, EEI funds the materials, students do research during the school year, and later present their findings at the end of the spring semester. I actually participated in the research summit this past year, and one of my teachers introduced me to the summit. My project focused on water conservation for households of any kind, while attempting to be as cost-effective as possible. This is the poster I created for the summit. I used 4 rain barrels and 3 rain barrel covers, from pea gravel to ping pong balls to paper. I placed them outside and measured how much water was lost across a 2-week time period in order to figure out which rain barrel and which rain barrel cover lost the least amount of water. The idea was that whoever had enough money to sustain themselves likely also had enough money to buy a barrel and a respective barrel cover in the event of rain or for general water use. I personally enjoyed the summit. I enjoyed being able to create my own experiment, and I enjoyed being able to test it in the same way. I also enjoyed being able to get professional feedback on how I can improve my current experiment and how I can create an alternate experiment for the future. And now I'll pass it to Damon.
Now we're going to talk about one of the first things we did this summer. First, we were introduced to these research articles where we read them and presented them. Now, the reason we even read these articles in the first place was to learn how scientific articles really look like, to do something we never done before, and to really get a good idea of how articles look like when we get to college. These articles also gave us a good background information on what EI does and why they do it. We did presentations about these articles to get good practice with public speaking and to learn our strengths and weaknesses as a team and as individuals. That presentation was probably the most complicated I've ever had to do. So I now pass it to Nisha, who will dive deeper into the articles.
Thanks, Damon. So personally, the articles were one of my favorite activities that we had to do in this internship. I asked to be on this part of the presentation because I felt really passionately about presenting what we'd learned about effective policy change when it comes to water conservation. This is something I believe our policymakers and the public should know so that we can implement these changes into the city and into our daily lives. So this is the name of the article that I presented. My article considered the role different sociodemographic factors played in household water consumption. From the article, I learned that water usage awareness and household water conservation culture have a substantial lasting impact. The study shows that when people are made aware of how much water they're using and why it's important, they're likely to be more conservative about their water choices. So, question for the audience, what do you guys do to save water? Yes? Yeah. Yeah, that's good. Yeah?
I've been teaching my kids to lather up their soap and turn the water off while they're washing their body, and then to turn the water back on with soap off.
Yeah, so these are all great examples of ways that you can save water in your daily life. And what this study focused on was trying to make people aware of how much water they can save. And what we realized is when you spread awareness, people are more likely to save water. So, oh my God, I'm sorry. My mistake. So what the study suggests on a larger scale is that policymakers should create community informational campaigns, which can look like community events or online campaigns, which would teach people about things that were just mentioned in the audience on how they can save water, and even implement water usage restrictions to decrease water usage. And what I thought when I was reading this article is that it would be helpful if these things go hand in hand so that residents can understand the reasoning behind these restrictions. This was interesting to me because it showed me concrete action the city could take to mitigate water usage and inform me on how I can conserve water in my life. Lastly, the article talked about how teaching kids about water conservation and water usage consequences leads to intergenerational transfers of knowledge, which was covered earlier in the presentation. And this makes it easier to spread awareness about water consumption. which is part of the reason as to why the Dallas EEI initiative is so important. And now Alan is going to tell you a little bit about what we did with GIS.
Thank you, Nisha, for your part. During our internship, we were introduced to Geographic Information Systems, or GIS in short, by our stats instructor, Mr. Ben from the UNT Biology Department. GIS is an incredibly strong program that helps compile data to create all kinds of maps. It turns out making maps is hard, but we explored core concepts like the different types of spatial data and how single and multi-layered pixels are used to analyze vegetation at different resolutions. We also learned about the trade-offs of different map projections, such as how the Mercator projection preserves direction for navigation, but can misrepresent and distort size. We also discussed how, We also discussed how satellites have made collecting data about the surface of our planet much more easier and efficient rather than collecting data in person, and how digital mapping has largely replaced paper maps. As interns, we got to toggle around and use ArcGIS Online, which is a kind of GIS software, to learn how map making works using online software and dataset inputs. Soon to be Dr. Ben showed us the diverse applications of GIS, including mapping animal distributions across the United States, national park data, and water use across the Dallas area. For one of our main projects, we created a map of the City of Dallas council districts and plotted data points to show the elementary schools and the middle schools that the Environmental Education Initiative team has visited over the years. To visually determine which schools had an impact from the team's visits, we used distinct symbols representing the impacted versus the non-impacted schools. One of my main takeaways from this project was getting hands-on experience with using GIS software to create digital maps that can really have a positive impact to everyone's lives who depend on it. However, my biggest takeaway about learning about GIS is that it can be applied to many different kinds of fields, from environmental management, remote sensing, public health, etc., showing that it's an important piece of technology that doesn't just apply to one specific field, but an interconnected network of its applications to a variety of fields around the world, which I never knew and was really surprising. Ultimately, this experience was incredibly cool, and I can see myself using these kinds of skills somehow, like, I don't know, in a future career like civil engineering. And I'll be passing it on to Damon. He'll be talking to you more about the UNT researchers we met during the summer.
Thank you, Alan. Like Alan said, I'll be talking about some of the researchers that we met at UNT. One of the people that we met on campus was Dr. Mager. He is an associate professor of biological sciences at UNT who specializes in ecotoxicology and ecophysiology of aquatic organisms. When he spoke to us, he boiled it down and said it comes down to physiology and toxicants. In other words, how toxins in the environment affect aquatic organisms' physiology. The most interesting topic he brought up to us had to be the fish treadmill. You're probably wondering what in the world is a fish treadmill. Well, Dr. Mager explained that it's exactly what it sounds like. It makes fish swim and it tests their cardio, and they use it to test. Goddamn. And how introducing different toxins affects the fish's physiology. I'll now pass it to Dominic, who will go into soon to be Dr. Ben.
I'm going to be introducing you guys to soon-to-be Dr. Ben Henderson. Ben is a PhD candidate and is set to officially earn his PhD in wildlife biology at the end of this year. He has also been our statistics and GIS instructor and has helped us with all the research we've engaged with, which coincidentally I will help present to you all a little later in the presentation. Ben teaches various ecology courses at UNT and has given us various tips and tricks on succeeding in a college setting. He has also spent many late nights working through our data and displaying it on many, many maps. We spent most of our internship with Ben, and he has taught us the importance of being adaptable, being attentive, and most of all, sitting in front of a lecture hall. And now I'll be passing it on to Alan.
Thank you, Dominic. Oopsies. The very first professor that we met during the summer was Dr. Ruthine Thompson, and she is a UNT professor and is the director of the DallasEEI program. I really appreciated Dr. Thompson's visit the very first day because she taught us about the importance of professional development because it leads to better job opportunities for the future. She stood out to me because she gave insight into the importance of making ourselves seem and behave professional to prepare for job interviews and to invest in good resumes for the future. My biggest takeaway from talking to Dr. Thompson was was the importance of socializing because socializing can make connections, can allow you to make connections with the right individuals, which leads to success in finding the right kinds of careers for the future and friends that could be trusted for life. Now passing it on to Olivia, she will introduce you to the field trips we visited this summer.
Thank you, Ellen. It's me again. Now that we told y'all about the researchers, I will be introducing you to the various field trips we've experienced at this internship. Additionally, we will also be going over our reactions, which are overviews dedicated to informing the public about these facilities and reserves. They can be infographics, vlogs, short videos, and so much more. This is a photo we took from our lovely supervisor, aka boss, Christina, from the outflow of the Trinity River that's returning to Central Wastewater Treatment Plant. When utilizing faucets, showers, or even your toilet, most people don't think about what happens after water goes down the drain. But the Dallas Utilities Central Wastewater Treatment Plant plays a critical role in protecting the public health and environment. This was one of our field trips that we went to. The treatment plant processes millions of gallons of wastewater each day. Its purpose is to remove contaminants from the water so that it can be cleaned and safely returned to local waterways. The wastewater treatment process begins when the wastewater enters the facility through large pipes. First, screens remove large debris such as trash, paper products, and waste, which is sludge. Next, the water is moved into setting tanks that is then thickened and processed to reduce the water content and stabilize the material. Additionally, they also have specialized equipment that helps separate the solid and liquid waste. In the meanwhile, the water continues through the biological treatment processes where microorganisms break down organic pollutants. After further filtration and disinfection, the treated water is safe enough to be released back into the environment. Here, I learned that removing sludge is an essential part of wastewater treatment because it prevents pollutants from entering rivers, streams, and lakes, while also helping maintain water quality for the community. Like stated prior, the purpose of reactions are to spread DallasEEI's mission by creating various media types that are presented on their socials. Here's the reaction that I made. This is an infographic, and I decided to put like everything I found cool on here. Like, I didn't know that Dallas Utility Central Wastewater Treatment had 13.5 kilovolt stations, just in case one of the treatment facilities gets shut down by like a storm. There's always a backup. And when you first get to Central, there is a profound odor. However, the serene environment immediately takes your mind off that. Overall, my favorite part of this field trip is going outside and seeing the machines that clean off the sludge and like filter out the water, and also learning that Central has an internship. So y'all see me there next year. Thank you, and now I'm gonna pass the mic over to Alan.
Thank you, Olivia, for your part. And now moving on to the next exciting field trip, which was Bachman Water Treatment Plant. It is one of the smallest among the 3 drinking water plants of Dallas, but it is a powerhouse that treats up to about 150 million gallons of water per day. We recently had the chance to learn directly from the staff and chemists at Bachman, but I can't really recall exactly what their names were, but I want to share the incredible process that transforms raw water into safe, clean drinking water. The first thing that surprised us is how heavily the treatment plant relies on advanced technology. Computers continuously monitor what's in the water to make sure that the treated water is up to state and federal standards, making sure that it is safe for the public. But what we found incredibly relieving is that the plant doesn't just rely on the machines. Chemists and analysts manually pull physical water samples every day to verify that the digital readings are accurate, ensuring our drinking water meets the quality standards. During the tour, I remember we met Ms. Griffin, a chemist who runs the bacteria lab. She explained the vital role of tracking biological data, measuring samples for E. coli, and monitoring strict incubation periods to meet water safety standards. If an automated testing machine ever has an issue, the chemists are right there to manually check the samples to make sure they keep up with quality standards. Sorry. Oopsies. Okay. Give me a moment, please. One of my favorite things that I learned about the plant is the use of the ozone facility to disinfect the water. As you can see in this slide, these are the ozone chambers that we got to see at Bachman. But what I found interesting to disinfect the water, the plant uses pure ozone gas. We learned that they need to make their own ozone because it is such an effective tool for destroying bacteria. To actually make the ozone gas, they vaporize liquid oxygen and nitrogen, running the gas through a generator that zaps the molecules to create the ozone. Give me a moment. I think the mouse is tripping. Yeah, I don't see the mouse.
I know, it's on the screen. We interrupt this program for a little bit of technical difficulty. I should click it now. Click here.
Wait, what if
Okay. Great.
Okay, and then sorry for the interruption. This gas, the ozone gas, then goes through diffusers, which are devices that break down water molecules to make tiny bubbles that destroy the bacteria with incredible efficiency. Overall, my biggest takeaway from this visit to Bachman is just how much effort goes into a single glass of tap water. Seeing operators work 24/7 to keep the plant running and constantly monitoring real-time trends showed me how vital the Bachman treatment plant is to the public. Here in this slide, you can see some of the reactions that my fellow peers did during our trip at Bachman. On the left, Darius made a reaction mainly focusing on the processes that the plant goes through to make sure that the treated water abides by the quality standards, and as well as some fun facts about the plant. Now, on the right, Naisha also made a reaction showing similar processes that the plant goes through to make sure that the treated water abides by the quality standards. Now passing it on to Naisha, she will talk to you about our visit to Lake Tawakoni.
Thanks, Alan. So our next field trip was to Lake Tawakoni. We went to Lake Tawakoni twice and hiked through the trails while looking for species such as deer, snakes, and cicadas. Mackenzie was our tour guide, who you can see pictured on the slide, and she gave us information about the plants that we came across and the history of the area, such as telling us about a tree where a rare communal spiderweb collected, which caused scientists from all over the country to come and study it. We traveled to Tawakoni the first time to leave leaf packs there so that we could study the organisms which would get trapped inside, and the second time was to collect the leaf packs to discover what we found. Each time, we wore water suits so that we could enter the lake and tie the leaf packs to trees in the water, and we'll touch back more on these leaf packs later in the presentation. So that same day, we also got the opportunity to learn about the Sabine River Authority. The SRA manages the water in the Sabine Basin off of the Gulf of Mexico, and they protect endangered species such as alligator snapping turtles and Toledo eels in exchange for being able to continue to do their work. To protect these species, they encourage the public to report animal sightings so that the SRA can record and use that data. Hearing about the fieldwork that they do to conduct research was really interesting because we got to see what wildlife protection and conservation actually looks like. We also got to pick through river plants to find bugs and other organisms to study under microscopes. And lastly, we got to see what the Iron Bridge Dam, which is on the slide, looks like and how it works, and where the water is sectioned off and controlled. So this is a reaction that I did for the SRA. The mayfly was an organism that my group found from the water from Lake Fork. Based on the kind of bugs we found, we could deduce the water quality because certain bugs are more tolerant of pollutants in the water than others. This is a picture of the mayfly that we found, and next to it an image off the internet. Mayflies can only survive in high quality water, so it was exciting for us to find them in our sample because it meant the water from Lake Fork was high quality. I loved interacting with the organisms in hands-on ways and figuring out from the present organisms if the ecosystem was healthy or not. So now I'm going to pass it off to Dominic to talk about JBS.
Thank you, Nisha. One field trip we had was going to the John Bunker Sands Wetland Center. But what is the John Bunker Sands Wetland Center? Well, it is a massive man-made marshland near Seagoville, Texas, that functions as a living water filter for the North Texas Municipal Water District. Millions of gallons of water move slowly through its 2,000 acres of native plants, which naturally clean the region's water supply, as opposed to the typical cost-intensive chemicals. Because this slow-moving water creates a thriving wetland ecosystem, the site also acts as a vital sanctuary for migratory birds and as a public classroom where visitors can see how nature can solve large-scale human infrastructure needs. Our visit to the wetlands highlighted the incredible diversity of a thriving ecosystem where we observed the interconnected species like dragonflies, caterpillars, frogs, cattails, and blooming lotus plants, all relying on the habitat's clean water and vegetation. On the left, we were lucky enough to spot a nutria, a giant rodent that has a tail similar to a rat. We learned that these rodents are actually very harmful for the environment and invasive. We also learned that about the center's impressive conservation initiatives, most notably an artificial electrical tower engineered to provide a safe nesting site for bald eagles. Over here on the right, we have the live camera of the bald eagle's nest from the JBS website. Now supporting a massive nest over 6 feet tall, this structure beautifully demonstrates how thoughtful conservation efforts can help wildlife thrive even within a human-modified landscapes. After our tour, we were given the chance to do hands-on water quality testing where we caught living organisms with a net in a section of the wetland. It was definitely the funnest part of our visit there because a few shrimp kept jumping towards us. Over here, we could see the reaction Olivia and I made for this field trip. These reactions are meant to show our findings during our EEI internship and can help later interns learn more about the internship. I'll now be passing our next field trip to Abel.
We then move on to the White Rock Pump Station. When we got there, we got presented information by the water utilities team. They talked to us about the pump station and the way it makes an impact in the process of sending water throughout the city of Dallas. In this tour, we learned how the team uses samples from lakes to test the water quality and how they check meters across the city to ensure water is safe for residents to drink. We also got to visit the Water Operations Control Center, where they monitor water flow throughout the city of Dallas, which was honestly my favorite part. It was very interesting to see how they work with technology to manage where the water goes and control temperature around surrounding areas. I also found it very shocking that this room runs 24/7 every day, even during holidays and bad weather conditions. And here are some reactions that I thought were interesting and informative. These reactions were made by our interns, Darius and Olivia, that present more information about the pump station, what it does, benefits, of the process and what we took away after touring there. These reactions help us teach others about the places that we went to. And I'll pass it off to Aileen.
So one of the most hands-on experiences during their internship was visiting Lila, which is a Louisville Lake Environmental Learning Area. And Lila is a natural preserve with prairies, forests, and scenic trails where people can enjoy activities such as camping, hiking, and bird watching. In fact, over 270 species can be found throughout the area. Lila is managed by several agencies, including the University of North Texas and the U.S. Army Corps of Engineers, with the mission of preserving local ecosystems while providing environmental education to the community. During our visit, we had the opportunity to hike the Blackjack Trail and participate in the leaf pack investigation. For those wondering, a leaf pack is a mesh bag filled with leaves that is placed under a stream and left there for several weeks to simulate a real occurrence in streams. Dirks and Hector will be going into more detail about this and what we found later in the presentation. My personal favorite part of a field trip, even though it was incredibly hot that day, was stepping out into nature. We got to experience how environmental scientists collect and analyze data in the fields, making science feel much more real and interactive. Sorry. So this is a reaction I did for this field trip, which is a blog. And this blog primarily focused on what we learned during our visit and explained our findings regarding the leaf packs. And if you would like to see more reactions, the EI team will be posting all of our reactions we made this year. Be sure to check them out at Instagram and Facebook.
All right. All right. Now that you've seen what we've done and where we've been, let's get into the research part of our internship. So, our research falls into two broad categories: water quality and water conservation. For water quality, we want to see what that looks like in Dallas and how it's determined. For water conservation, we want to analyze what water consumption looks like in Dallas, understand why it looks like that, and figure out where EEI should target schools. Going on to the water quality aspects. Coming into this internship, I personally had no idea where my used water came from and how it really got into my home. However, throughout this internship, I've been able to learn about the long filtration process Dallas uses for treating wastewater, the fact that they have the best tasting drinking water in Texas, and the multitude of different tests they use to maintain and preserve their water quality. Within the internship, we did our own field research on water quality in the form of leaf packs. Last year's interns recommended that we should get stronger bags for the leaf packs and apply mixed methods in the event that the leaf packs do not meet expectations. So, I know you're probably wondering, so we'll get into it. What is a leaf pack? Well, you have a natural and an artificial leaf pack. A natural leaf pack is the accumulation of leaves that acts as both a habitat and a food source for aquatic insects and macroinvertebrates. The artificial variant of this effectively does the same thing, but acts more so as a replication in order to test water quality using the biotic index. The artificial leaf pack sits in the stream for a period of time, and once it's retrieved, the quality or the quantity and type of macroinvertebrates allow us to better understand the water quality. So here is a set of macroinvertebrates from sensitive to pollution to tolerant to pollution. Organisms that are sensitive to pollution are not going to be found in polluted areas, and organisms that are tolerant to pollution can thrive anywhere, meaning they can be found in both polluted and non-polluted areas. When looking at leaf packs, these are the types of macroinvertebrates that we should be looking out for. How many kinds of macroinvertebrates, how many organisms there are, and how tolerant they are to pollution all play a role in determining water quality. So, now that you know a little bit more about the leaf packs, here's an outline for you to see what we did and what we found. In Lila, we put a leaf pack in the Blackjack Trail, and we attempted to put another at a different trail, but that trail was closed to the public at the time. We also plan to apply mixed methods in the form of kicknet sampling at the dam, and in Lake Tawakoni, we put in 3 leaf packs and plan to apply pond dipping, similar to what Dominic talked about in her wetland slide. So, for our findings, when we went to retrieve the leaf pack in Lila, we were excited because it was submerged, as last year's interns noted that their leaf pack was dry and found on land. However, upon further investigation, we found that our leaf pack was filled with silt, as you can see with the picture above. We did still find 2 organisms though. a crayfish, and a dragonfly nymph. So, how do you assess a leaf pack? Well, for the leaf pack in Layla, the contents yielded were not to our expectations, as there was an abundance of silts and a lack of macroinvertebrates. When analyzing a leaf pack, we fill out 8 pages of information, but not all of that information is just on the macroinvertebrates. In fact, some pages ask us about the stream characteristics, being the types of habitat and substrate, weather events, as well as the area of surrounding the stream. Based on our Based on the questions asked and the experience of our mentors, we hypothesized that the reason the leaf pack was mostly empty was due to the location and the weather. So, this is the biotic index data sheet, which we use to record the macroinvertebrates that we found. We use the formula given in order to determine the pollution tolerance index rating, which allows us to better predict water quality. At Lila, we found 2 somewhat sensitive organisms, which resulted in our PTI being a value of 4. Because this value is lower than 10, the water quality around the leaf pack was deemed as poor. However, this doesn't necessarily mean that the water downstream and upstream is equally intolerable to life, but rather just this area in specific. Even though the PTI was low, we wouldn't take this as the ultimate test of water quality because of the complications that we found. More leaf packs and potentially other types of quality testing would allow us to be more confident in the water quality of this area. So, getting into the mixed methods. Ben and Christina have both done kicknet sampling at the dam outflow in Lila for the sake of water quality testing. However, we were unable to do the same because it was deemed too dangerous with the amount of water being let out at the time. And now I'll give it to Hector on the Lake Tawakoni side.
Thank you, Darius. Now I'm going to tell what we found at our leaf packs at Lake Tawakoni State Park. When we arrived at our leaf pack site, all 3 were submerged. We could see our lines going into the water. Unfortunately, when we went to retrieve them, all 3 were ripped. Because all 3 of our leaf packs were ripped, we did not have any data for the biotic index and the pollution tolerance rating. We did learn from the park ranger that there have been some severe storms that greatly contributed to the leaf packs ripping. Welcome to the world of science. Trial and error is what we do. Furthermore, we were also unable to apply mixed methods due to time constraints. However, people from the SRA, Sabine River Authority, brought us a sample for us to look at. While we were unsuccessful in retrieving a sample, the SRA had an ice chest full of samples for us to look through from Lake Fork Creek. We were also able to find many macroinvertebrates which showed promise in the water quality at Lake Fork. The SRA also helped us to make tentative plans for next year's interns leaf packs. I'll tell you a little bit more about it in just a second. Before we get into what we should do next year, shown here are the types of macroinvertebrates that we found in the small sample. As you can see from the check marks, there are many organisms from all 3 categories, and this is promising for the water quality as we see various types of species interacting within the sample. We were also, All right, so conclusion. At Lila, we were only able to place 1 leaf pack at 1 location because our secondary location was closed at the time. That leaf pack was filled with silt and did not give us an accurate picture of the water quality in the area. Mixed methods were not possible due to safety concerns at the dam outlook. At Tawakoni, we were able to place 3 leaf packs, but however, we found all 3 of them ripped, likely due to turbulence in the water from the storms. Mixed methods at the state park were ruled out due to time constraints, but looking at the dipping from the SRA gives us some ideas. Sorry. Gives us some ideas about next year. Previous interns recommend that we get stronger bags and use mixed methods. We did get the stronger bags and we attempted mixed methods. We have brainstormed a few new things for next year's interns. Now they can do it a little differently and hopefully have better luck than we did. you help me find the mouse? Sorry.
It's on the screen. Which way? That way.
Sorry for the delay. First, when we met with the SRA, they offered for us to look through their Lake Fork location. Through a little further than the Tawakoni location, they have both a lake and a creek, which they told us is where they pulled their samples from. And there should be water, unlike sometimes at Lila. Another idea we had is that next year's interns can go out to the Lake Fork location 3 times instead of 2. Once to put out the leaf packs and then twice to get the results. This would help with the time constraint issue we ran into at Lake Tawakoni. Okay, so why do we care? There is a relationship between water quality and water conservation. If the quality of the water is poor, what is there to save? Talking to the experts at the treatment plants and the water quality team, we learned that the changes in water quality can impact the systems used to clean the water we all use every day. The longer it's in the system to be clean, the less we have available to be used. Thus, the need for conservation. We have to protect the water to save it. And I'll pass it to Dominic now.
All right, thank you, Hector and Darius. Now that we better understand the relationship between water quality and water conservation, we want to talk to you about our water conservation research. But before we get into what we did this year, I'd like to give you a rundown of our past studies. Back in 2013, the DallasEEI saturated or saw every class at 4 schools that are located in the 75224 zip code. After saturation and running statistical analysis, the interns from 2013 found that water usage was statistically significantly lower in those school zones. The homes in the study saved an average of 49 gallons of water a month, which adds up to a potential savings of 2.8 million gallons a year across the area. However, one of the biggest limitations was that this study did not include a control group. This map was made by 2019 interns with 2018 consumption data from the city of Dallas. The interns found that the 75224 zip code, the area circled in yellow, from the previous EEI study was in a lower water usage area. So they challenged the EEI team to find an area in a higher water usage area to replicate the study. After a COVID intermission where EEI was not in schools but everything went virtual instead, zip code 75248, which is circled in pink, was identified as the next study area. EEI saturated 2 schools and added a control school that they did not visit. Following the education initiative, water consumption decreased across all 3 schools, with our 2 targeted districts seeing a larger drop than the control group. Although this difference did not meet the threshold for statistical significance, its social impact is highly encouraging because it demonstrates that conservation education can potentially influence behavior. Looking closely at the household data against the control baseline, the results are incredibly promising. In fact, Brentfield and Spring Creek combined to save approximately 10 million gallons of water in just the first year of post-treatment. At the conclusion of the last study, the interns noticed this map was made using data from the city of Dallas for the year 2018. The 2025 interns recommended we update the water usage map to better reflect the current state of the city. And now I'll pass it on to Suda, which will explain this a lot more further.
Hi, friends. Who's excited to be here? Yeah? Okay, I'm gonna level with y'all. I have a lot of stuff to get through, and I tend to talk pretty fast. So if I'm talking too fast and you need me to slow down, or you want me to go back or repeat myself, just raise your hand and we'll go back to it. Cool? All right, let's go. So this brings us to our research questions about water conservation. The 2025 interns recommended that we analyze what water consumption looks like in Dallas. And with that in mind, we have what does water consumption look like in Dallas? Why does it look the way it does? And where should EEI go next? So here we have a screenshot of the massive amount of data the city sent us. The file encompassed over 220,000 water accounts, but to answer our questions, we have to clean this data appropriately. We included only single-family homes, individually metered apartments, duplexes, townhomes, and manufactured homes in the city of Dallas. We also took out any data with negative water consumption. How do people use negative amounts of water? Great question. We don't know either. Since it was definitely an error, we took it out and just moved on. We then filtered out any house with less than 9 months of water consumption data. After cleaning the data, we were left with 225,145 accounts. So we've cleaned this data, and now we're able to look at our average monthly water consumption by zip code for the year 2025. This answers our first water conservation research question: what does water consumption look like in Dallas? We took the average water consumption by month for each zip code, and then we calculated the mean of the monthly average water consumption by zip code, resulting in the map you see on the right. Now, on the right of this page, we have the output from R, which is the statistical program that we use to create some of these maps. So this shows the average water usage per zip code for each month of 2025. The darker the blue, the more water is being used in that zip code. Hello? Okay. This brings us to our next question, which is, why did the data look like this? Or in other words, what exactly impacts the water consumption in Dallas? Now, to start looking at what influences water consumption, we looked at previous interns' presentations to see what variables they listed. Now, we did things a little differently this year because we had a different question, and we're going to tell you about that. But first, let's talk about some of the variables from previous interns' questions that are constant across Dallas. As you can see here, all of Dallas is in the Texas Blackland Prairie Level 3 ecoregion, so this is uniformly influencing water consumption. The same thing applies to temperature. It's pretty consistent across Dallas. And if you notice this map looking pretty similar to the temperature map, it's because precipitation is also similar to temperature, and it's pretty consistent across Dallas. We can see here that the price of water, irrigation ordinance, and marketing is also the same across the entire city. For marketing specifically, we are unaware of any targeted marketing campaigns, meaning that everyone has the equal opportunity to get marketing. Yay! We all get ads. So, now that we've covered some of the previous interns' variables, let's get to some of the different things we looked at this summer. When we began looking at learning GIS, one of our first assignments was downloading census data and mapping it across the city. Each of the interns picked a specific covariate that they thought might influence water consumption, resulting in the list on the left. In addition to our 10 census covariates, we decided to include canopy cover and impervious surface and their connection to water consumption after discussing with them. Okay, so now we have a lot of covariates. And so we talked to Ben, who informed us if we used too many covariates in the model, it would break the assumptions required of our model, leading to misleading results. It would also break his computer, so we decided against breaking his computer, and as a group, we brainstormed 5 covariates that we would use in our model. So what's really interesting about these covariates is a lot of them are related. So, for example, per capita income is closely related to maximum degree earned, which is really closely related to median rent. And given the similarities in trends, we were able to take this large set and cut it down to a reduced set of covariates to run our model. So I'm going to quickly walk you guys through these variables so that we're all on the same page, okay? Yeah? Okay, let's go. So for me, this is the one that was most confusing. Average household size refers to the number of individuals living in a house, not the square footage. Percent canopy cover is the amount of landscape covered by tree canopy, which is defined as the area of trees divided by the area of landscape. It's estimated by satellite imagery showing a 30 by 30 meter pixel, but crucially, this does not include grass. Now, impervious surface is the amount of concrete and stuff that holds heat better divided by the amount of landscape. And finally, median year built and median income per zip code are pretty self-explanatory. Okay, so now we get to make a model, which is basically saying, given all of these independent factors, how can we predict a stated outcome? For us, this is basically saying, given our set of covariates, how can we predict water consumption per zip code in Dallas? We check this by running a model called a multiple linear regression model. Slight segue, but who remembers y equals mx plus b from algebra? Yeah? Okay, awesome. So that's basically all we're doing here. We map each covariate to an independent variable, and we're checking to see if our covariates explain the water consumption output. So when we ran this model, we concluded that our results are statistically significant, which basically means that at least one of our covariates does statistically influence Dallas water consumption. Now we know the results of the model are statistically significant because the p-value is less than 0.05, which is the threshold for statistical significance. We then took a look at our adjusted R-squared, which is the amount of variance explained while accounting for the number of predictor variables. Our adjusted R-squared of 0.3785 indicates that approximately 38% of water consumption can be explained by our covariates, while accounting for the number of covariates in our model. Now, looking at this table from the model, you can see each of the covariates and their coefficient and p-values. The coefficient is the size and direction of the relationship between the independent and dependent variables. In other words, for every unit of change, the coefficient is how much the output, or water consumption in our case, changes. We are going to focus on the two covariates that show statistical significance, median income and household size. And remember, household size still refers to how many people are in the house. Now, each of these has a p-value of less than 0.05. So in other words, for these two covariates, let's take income for instance. For every $1,000 that the median income increases, household consumption increases by 56 gallons per month. And for every unit increase of the covariate, we'll see a proportionate increase in water consumption. So if we look at household size and that increases by one person, we see a decrease in water consumption by 2,878 gallons per month. Logically, this does not sound correct. It's really weird that increasing the size of a household relates to a total decrease in water consumption. So y'all might be thinking, wow, she sounds like she sucks at statistics. And maybe I do, but not in this case. We'll get to it in just a bit. Let's see. Okay, map time. As we can see here, this map represents the over and under prediction of the MLR model. In South Dallas, this model seems to work pretty well, but as we go further north, there's more deviation from the model, as seen by the bright red and blue. This model is under-predicting the amount of water consumed when the region is red, and over-predicting when the region is blue. These deviations are called standard residuals. We noticed that all of the reds were in a similar location, and all of the blues were also near one another. This finding led us to wonder if that spatial structure is significant. So, to determine if that spatial structure was significant, we ran the Moran's I test for spatial autocorrelation. The results showed the Moran's I value was positive and statistically significant. But what even is the Moran's I value? Well, basically it measures spatial autocorrelation, or whether areas that are close together share similar values. We're running this test to check if our standardized residual values from the last map are mathematically clumped together. If they are, it tells us that there's probably some spatial variation or structure we should consider. Now, positive Moran's I, as we see here, indicates that similar values are clumping together and that the clumping is significant. And because we found significant positive spatial autocorrelation, we can conclude that our multiple linear regression model fails to account for spatial structure in our covariates. We'll see this as we look at the maps of our covariates. So here we can see a clear gradient from north to south Dallas, which implies that the behavior of people throughout the city is different. For example, we can see that North Dallas uses more water than South Dallas, but we can also see that more of the homes in South Dallas are older than those in North Dallas. Similarly, the income in North Dallas is higher than in South, and there are more people per house in South Dallas than North. Interestingly, there's more tree cover in South Dallas versus North, and more impervious surface in North Dallas versus South. So, what does all this mean? It means that we're going to do some more statistics. Can we get a whoop whoop? We decided to take the spatial structure into account by running a model that accounts for spatial autocorrelation called a multi-scale geographically weighted regression, or an MGWR. And with the power of GIS, this model should give us more accurate predictions of our covariates relationships to water consumption. This figure we see here demonstrates the difference between our models. Our original model, the MLR, assumes that behaviors are the same across the entire city. It's illustrated by the maps next to the OLS, but the MGWR, however, it recognizes that behaviors vary by zip code, and it accounts for that within this model. So we ran this, and it improved our adjusted R squared from 0.379 to 0.535, which means our new model accounts for an additional 15.6% of variation. The model also successfully accounted for spatial autocorrelation because our Moran's I for the MGWR is no longer statistically significant. With the MGWR, the same two covariates were found to be statistically significant, but now we have a more accurate coefficient, meaning for every $1,000 the median income increases, household consumption increases by 45 gallons per month. And if household size increases by one person, we see a decrease in water consumption by 2,408 gallons per month. Guys, I know it still sounds really weird, but we're gonna get to it. Trust, believe in me. Income is statistically significant across all zip codes, but there is this interesting thing about house size, which we'll get to in just a couple of slides. Now, this map we have here still shows over and under prediction in Dallas, but that makes sense considering that we're looking at people. The model cannot possibly account for all behaviors. However, although it might not be evident looking at the map, the new model now significantly accounts for spatial autocorrelation and provides a more accurate result, which we can conclude from our non-significant Moran's I. The new model additionally shows us how each of our covariates relationships to water consumption vary across the city of Dallas. I'm going to show you this using, guess what? A few more maps. Okay, so starting this off, we're going to look at our covariate of median income. If you'll remember, this covariate was statistically significant in our model. This map is showing us that it's statistically significant across the entire city of Dallas. We've denoted non-significant regions with hash marks, which we don't see here. It's kind of cool that the relationship between median income and water consumption in North Dallas was stronger than in South Dallas, meaning that higher income leads to a greater level of water consumption in North Dallas over South Dallas. This is indicated with different colors, with red showing a stronger relationship between covariate and water consumption. Now, remember household size and those numbers we said we'd come back to? It's now. So average household size was the other statistically significant covariate, but you'll notice that only the 4 zip codes in Southeast Dallas that we have marked are statistically significant with no hatch marks. This means the relationship is only meaningful in those 4 zip codes. Okay, so the big question, why is it decreasing? Well, that's a really good question. It doesn't make a lot of sense to us that the lowest income, highest density area of Dallas reduces water consumption when additional people are added to the household. But we're not the only people who have noticed this trend either. Let's talk about why this is. Fundamentally, it sounds like if we increase household size by 1 person, we will see a reduction in water consumption by 2,000-ish gallons. But unfortunately, that's not quite how this works, because this implies that increasing household size causes a reduction in water consumption. In reality, these 4 zip codes are high-density, low-income zip codes, which means that there's more people per household on average. And they use less water in general, which means that the relationship between house size and water consumption is correlated, not causatory. Larger household size is associated with lower water use. However, this does not account for differing degrees of outdoor water use in Dallas. In more wealthy areas, there is much more expendable water use, especially outdoor water use due to behavioral differences associated with income. Now, these differences might include HOA requirements for lawn irrigation, private swimming pools, large gardens, and the presence of thirsty non-native plants. Lower income areas tend to eliminate unnecessary water usage and are often not responsible for their own outdoor water use, given the prevalence of multifamily homes. These extreme differences in water use behaviors, especially outdoor water, likely contribute to our unusual findings. Now, interestingly, a similar study examining water use in Central Texas also found a negative relationship between household size and water consumption, so we're not the only ones noticing these unusual results. We believe that next year's interns should go out and ground truth, which basically means go out into the neighborhood and look for any unexplained factors that are influencing these results. They should also incorporate additional data on lot size, irrigation behavior, and the presence of swimming pools and other discretionary sources of outdoor water consumption for future models. Okay, that was weird. Let's talk about one more interesting result. So we might notice here that our entire map is hash marked. Canopy cover was not a statistically significant covariate, but we found it interesting to look at. Now, weirdly enough, the relationship between canopy cover and water consumption across Dallas is wildly different. This means that tree cover in South Dallas corresponds with reduced water use, but in North Dallas, higher canopy coverage corresponds with higher water use. Green corresponds with lower water usage per additional 1% of area covered by canopy, and red represents higher water usage. Now, this could be a condition of tree type. South Dallas has native trees that have been here for hundreds of years and are already established, but North Dallas is planting a lot of non-native trees that suck up water. Okay, that was a lot of information, but we're almost through. Let's all take a deep breath. Let's all take a sip of water. This is mostly for my benefit. Okay. Fundamentally, our question was, why does water consumption in Dallas look the way it does? But even with our improved model, we explained just over 50% of variance, with only 2 of our covariates being statistically significant. I want to quickly talk about a quote that basically Dr. Ben introduced us to. George Box, a famous statistician, once said, "All models are wrong, but some are useful." When we were looking at everything we found, one of the things we found interesting was the fact that we couldn't account for every behavior because we're looking at humans. It's impossible to determine why someone may water their lawn at 3 in the morning versus not water it at all. But this quote kind of describes the journey we went on to understand why water consumption looks the way it does. It's impossible to create a perfect model that accounts for every behavior, but we did catch a glimpse of what's going on. So this is going to lead us into a final question, which is, where should EEI go next? So I'm going to go take a breather and hand this one over to Dominic. Thank you.
All right, thank you, Suda. The Dallas EEI program visits public, private, and charter schools. So, why do we choose to conduct our research with public elementary schools in a district? Well, the answer comes down to accuracy and representation. Public elementary schools provide more accurate geographic data of the local population compared to public and middle schools, which cover a larger area and often draw from multiple neighborhoods or even across different districts, because elementary schools tend to serve families who live in a closer proximity to the campus. In private and charter schools, there is generally not a defined school zone or boundary, as people can pay to attend or enter a lottery to attend from varying locations, some even outside the city in which the school is found. As you can see, each school has a well-defined zone. The elementary zones, as we talked about, are generally smaller, which means most students attending an elementary school actually live nearby, making the school a strong reflection of the surrounding community. Looking at the circles, in the elementary circle, you can see 5 school zones. Now, if you look at the middle school and high school zones, you'll notice they're much larger and often pulled from multiple elementary schools. Choosing them to study would increase variability in where students are coming from and would make it harder for us to tie our data back to one specific neighborhood or zip code. Again, referencing the circles on the map, one middle school pulls from all 5 of the elementary schools, and the high school in the circle pulls from even more elementary schools and multiple middle schools. By reducing variability in where students come from, we improve the accuracy of our sample. Pulling these maps from before, on the left, we have the research area from 2013, and on the right, we have the research area from 2025. In both research areas, the colored blocks represent elementary school zones. Inside those school zones, the little dots we see in each of those school zones are water consumption accounts. I show you this again to reiterate why EI uses public elementary schools as a way to limit variation. Now, let's look at a new map. So on this map, it shows you all public elementary schools in Dallas. Elementary schools with a blue star have received EI water lessons at least once. The schools represented by the red dots have never received EI water lessons. Using this map, we were able to locate zip codes where EI has not taught the water lessons, which there isn't that many of. Based on what we talked about before, we wanted to find a zip code where there were at least 2 schools so that the team could saturate one and keep the other as a control. So we're going to look at 3 zip codes that they could target. These are the 3 zip codes that have at least 2 schools that EI has not provided water lessons to. The EI team will need to reach out to the schools in this coming year and attempt to get into one or more of these areas for their replication study. If we get to choose, we think it would be really interesting to target both 75225 and 75205 and have a control and impacted school in each of those zip codes. In other words, the map on the left. We started off with 3 questions. What does consumption look like, and why does it look like that? And where should EI go next to replicate this study? Well, the first question is mapped on the left. The second, well, Suda's still chugging water. But seriously, guys, behaviors and their influence on water consumption is really fascinating. While we did not get every answer and we have even more questions, that just means future interns get to have as much fun as we did digging into these questions. For our last questions, as mentioned, we would love for EI to get into not 1, but 2 zip codes, that being 75225 and 75205, to see what happens in those areas that are both higher water usage areas and areas the model had a hard time predicting accurately. And with that, we're done. I'm going to hand it off to Eileen to wrap us up.
So now that we have reached our conclusion, we are going to share with you our biggest takeaways. So overall, we had a great time together and learned many things along the way. We would like to say our biggest takeaways that we got from this internship. Personally, I learned that it's totally okay to get out of your comfort zone because that's when you can grow as a person.
Stay consistent, and everyone you meet is a potential contact, meaning that everywhere you go, you always have to socialize.
I'm going to bed early because it'll affect you sooner rather than later.
My takeaway is that the insects won't hurt you. They're just trying to do their own thing.
Don't be afraid of trying something new. If I didn't take the chance to try this internship out, I would have never had the experience I'd had.
Basically, be a good presenter to help me further in college.
I love getting hands-on experience with fieldwork so that I could understand what being a scientist actually looks like.
There's more to the world than outside your home, given all the places we saw and all the places we went.
I learned how to ask questions and stay curious. It's the only way you can have fun when you're doing a lot of learning.
My biggest takeaway is that you work better in a team because a lot of mine's it's better than one.
Thank you for listening to our 2026 Dallas EEI final presentation. We are so grateful for this opportunity that was granted to us. Throughout this internship, we learned from environmental researchers, organizations, and other professionals how our water is conserved and the measures that are taken to ensure that the city of Dallas is provided with clean water. Additionally, we learned how to handle environmental data through GIS and statistics. Not only were we able to expand our knowledge on environmental science, but it's inspired us to become engaged, informed, and responsible members of our community. Thank you once again for supporting the Dallas EEI program, and I really hope that you enjoyed our presentation. Thank you.